So finally, in this lecture, we are going to talk about cryptography, a great application of all of this stuff we have been talking about. And we use it daily, even if we are not aware of it. It's everywhere, from your web browsing to your credit card usage, bank transactions, or email account access. Anything you can think of that requires privacy includes a sort of cryptography in one way or another. So what is it? It's essentially the study of techniques to communicate or store data in a secure way. So when we say secure, what does it mean? In such a way that parties other than the intended ones are not able to access the content, the original content, even if they access the communication or the storage. So you communicate or transmit or store your data in such a way that even if somebody sees the stored value or the transmitted value, they will not be able to understand the original data that you intend to send or store. So you encrypt at the originating point and you decrypt at the destination. And essentially, we have two types of methods for cryptography. The first one is what we call private key or symmetric key cryptography. Essentially, this is a bijection, so a one-to-one and on-to function defined from the input alphabet to the cipher alphabet, and we call this the encryption function. A very typical and simple example is the Caesar's cipher. Here you just assign numbers to the letters. For instance, using English alphabet, you can assign 0 to A, 1 to B, etc. up to Z. And you can define the function as a shift cipher. So this we call a shift cipher. X plus K modulo 26. 26 is the number of symbols here. And any letter here is just shifted by K, but in a cyclic manner, of course, because you do not move about 25. So if K is 1, for instance, A becomes 1, B becomes 2, C becomes 3, etc., up to Y becomes 25, and Z itself becomes 0. So it's cyclic. And obviously, if you know the function, the encryption function, you can simply find the decryption function by inverting the encryption function, because this is a bijection. You are guaranteed to have the inverse. And so when you know how to encrypt, you automatically know how to decrypt. There are other functions that can be used in private key cryptography. For instance, this is an affine encryption function, A times X plus K modulo 26, that works on the same alphabet, and this can be decrypted using the inverse function. Obviously here A should be selected in such a way that it's co-prime with 26, the modulus value, so that its multiplicative inverse is guaranteed to exist. Obviously, private key cryptography is practically used in our daily lives. We have certain standards for this. For instance, Data Encryption Standard, DES, and Advanced Encryption Standard, AES. Also, other examples include cryptographic hash functions such as MD5 or SHA, the secure hash algorithm. But these are not to be decrypted back. These are hash functions. They just produce the encrypted result, and they are generally used for authentication, whether the data you have matches the original one. So you don't really decrypt back. One important point here is obviously to use private key cryptography in communications, for instance. Both parties, the transmitter and the receiver, must agree on the private key. So what function to use to encrypt the data so that it will be possible to decrypt at the other side. So both sides need to know this function before the data exchange. But obviously this is a problem because these are remote parties, and before the communications, how do you communicate the cipher itself from one side to the other? Okay, and it's due to the definition of private key cryptography, as I have stated earlier, when you know how to encrypt, you automatically know how to decrypt because the inverse function is easy to find. And therefore, you cannot just simply transmit, okay, this is my encryption function. Because if somebody is eavesdropping, they are going to also find out how you are encrypting, and then it will be very easy for them to decrypt the transmitted messages. So you do not want that. So this is the problem regarding private key cryptography.